You can say that u is equal to this vector here plus this vector here. Who doesn't see it? v1 plus v2 is equal to v. Who doesn't see it? v1 plus v2 is equal to u. Now, why would you want to do such a thing? I don't know. Or you could say is equal to v1 plus v2. U is equal to v1 plus v2. Why would you want to do that? I don't know. But I think everybody would like to do this one here. I think everybody. Now that one is not an easy problem. It is quite a difficult problem. The way I've drawn it makes it look easy. But you can imagine in 20 dimensions. You cannot, huh? Let us just say, break up this vector as that vector plus that vector. One of which is parallel to this, and the other one is perpendicular to this. What I did with the frictional problem parallel to this and perpendicular to this. B1, B2. Because this is the right way to do this problem. I work in strange directions. Now, the problem is what I did. It's not this one. And it's not this one here. But this one, where this is perpendicular to this. It's a very hard problem. And how do we do it? Well, I'm going to call this one A, vector A. And I'm going to call this one vector B. What I want is A plus B to equal U. I want A to be in the direction of V, but most important, I need B to be perpendicular to A. That is the most important. Here, A plus B is equal to U, and A is in the direction of V, but B is not perpendicular to V. That's not going to do the trick. Clear? This is what I mean by orthogonal projection. You're going to have a vector V, you're going to have a vector U, and you want to write U as the sum of two vectors, A and B. Moreover, A is parallel to B, and B is orthogonal to V. Clear? My question is, what is A? What is B? Most certainly it depends on U. Most certainly it depends on V. What is B? Most certainly it depends on U. Most certainly it depends on V. So I need to find these as a function of U and V. Well, this one we don't have to worry about. This one is easy. Once I find A, how do I find B? Huh? Once I find A, how do I find B?
Subtract.
Huh?
Pythagorean theorem.
No.
Subtract it.
Subtract it.
No.
B will be U minus A.
Yeah.
Khalas. Finished. Yes. Now here is the problem. How do I assure that A is parallel to V? The Jews have their breakfast. How do I assure that A is parallel to V? Who will have their breakfast?
Make sure they have the same direction.
How do I do that?
Inverse tangent.
Who will have their breakfast? I will say that A is a scalar multiple of V. Who understands that? Clear. Well, this one is easy. Once you find A, your V will be U minus A. The question is, how do I ensure number two? A is parallel to V, and the answer is A is a scalar multiple of V. Clear? It remains for me to do what? Mr. Harris, find that scalar multiple. I do not want to go too short. I do not want to go too far. I have to get just right. This is perpendicular to this. This is a candidate. Why? Because it is in the right direction. But it is not correct. Why? Because most certainly A and B add to U, and A is in the direction of V, but B is not perpendicular. That is to say, my alpha was too small. Or you could say, take this amount. Well, certainly A is in the direction of B. And then if I do this, A plus B will add up to V. But my problem is now, V is not orthogonal to B is not orthogonal to V. That is to say, I've taken too much of V. So now I've shoved all the work here. How much V so that they are exactly perpendicular? Anybody know? How much V so that they are exactly perpendicular? going to need to do some calculus. That is to say, find the amount that's going to minimize this distance. If I go too much, this is too much. If I go too short, distance is still big. So I want to find the alpha that is going to minimize this distance. And by minimization, I mean differentiate. Right? The question is, what is this alpha? Is it 2/3 V, 1/2 V, 3/4 V? And the answer is, it depends on U and V. Not too much V. Many V's. Okay? It depends on how they are inclined to each other. It depends on how they are inclined to each other. And when we talk about inclination, we're talking about dot product.